Video, we're going to graph some introductory level rational functions. So we're not going to do anything but maybe a linear over linear. In this one, this f of x is equal to 4 over x minus 2 is find the vertical asymptotes. Now you can find the vertical asymptotes by setting the denominator equal to 0. So if we set x minus 2 equal to 0, then that'll give us x equals 2 is our vertical asymptote. And we can graph that by going to the x-axis at 2 and putting a vertical line here. Okay, so this will be a line that the function cannot cross. Okay, it's like a barrier. Okay, now for the horizontal asymptote, okay, you're looking on whether or not the leading exponent, the highest exponent, is bigger on top or on bottom, or if they're the same. Okay, so in this one, you don't have an x at all in the numerator on top. So your bigger exponent is this x term. It's x to the 1 power. So that's your highest power of x that you have in both the numerator and the denominator. So since the exponent's bigger on bottom, then that is going to be y equals 0 is our horizontal asymptote. Okay, now a horizontal asymptote, if we're graphing, if it's at y equal to 0, is going to be the x-axis. Now keep in mind that horizontal asymptotes you can cross, but they're more like a guideline. So as we approach negative infinity, this graph will go somewhere around this line. And as we approach positive infinity, this graph will go somewhere around this line. Okay, so we might cross it, we might not. But vertical asymptotes you cannot cross. Okay, now for x-intercepts, to find x-intercepts, you need to set the numerator equal to 0 if it has a variable. Okay, the reason for that being is if we set the whole thing equal to 0, if we said 4 over x minus 2 is equal to 0, the first thing you do to solve this is multiply by the denominator to get rid of it, right? But if you multiplied both sides by x minus 2, right here, it would cancel, right? But the other side would cancel as well because you're multiplying by 0. So you're actually just getting the numerator equal to 0. And since there's no x term here, since the numerator does not have an x, we can't solve it, so there's no solution. So this is going to be none. There's no x-intercepts. Okay. Y-intercepts, you set x equal to 0. So you do f of 0, which would be 4 over 0 minus 2. And that ends up being negative 2. So y is equal to negative 2 is where we cross. Okay, so I put a little point right there. All right, now we can plot some other points around this on both sides to see sort of what this thing is doing. So we'll make like a T graph here. Okay, so let's go ahead and do that. X and y, remember y is f of x. So we've already got x equals 0, right? Because that's where the y-intercept is. How about x equals 1? What if I plug in a 1 into this function? Well, the function is 4 over x minus 2, so it would be 4 over 1 minus 2. Okay, let me do this off to the side. So 4 over 1 minus 2 is 4 over negative 1, which is negative 4. Okay, so that gives us the point 1, negative 4. So 1 on the x-axis and negative 4 on the y. Okay, let's do negative 1. So if I do negative 1, which is still on the left side of the vertical asymptote, if I do negative 1, that would be 4 over negative 1 minus 2, which is 4 over negative 3, or negative 4/3. Okay, so if I go to negative 1, I get negative 4/3, which is just a little more negative than 1. So it's going to be somewhere around there. Okay, so noting that this is a barrier, we can kind of, this is a barrier, this is kind of a guideline. So this function is going to keep going down here by this asymptote, right? And then it's going to kind of hover around this and get closer and closer to it. So the left side of this thing is going to kind of look like this. Okay, and as we go farther and farther out here, it's going to get closer and closer to both of these axes, okay, or both of these asymptotes. All right, so let's try a few points on the other side. If we try a few points on the other side, let's say we have, oh, I didn't write this down, 4/3. Let's say we want to try a point on the other side, say 3. Okay, so if we plug in 3, okay, so it would be 4 over 3 minus 2. That's 4 over 1. which is 4. So we'll plug in a 3, I get a 4. Okay, so 3 gives me a 4, so 0.34. Let's plug in a 4. Okay, so you plug in a 4. On bottom, you get 4 minus 2, and that's 4 over 2, which is 2. Okay, so if I plug in a 4, I get a 2. So 4 on the x-axis, 2 on the y. Let's do one more of those. So let's plug in a, maybe not a 5. Let's plug in a 6. Yeah, 6. So let's plug in a 6. So that will give us 4 over 6 minus 2. Can't see. 4 over 6 minus 2 is equal to 4 over 4, which is equal to 1. So the reason I chose 6 instead of 5 is because if I would have chose 5, this would have turned into a fraction. But choosing 6, it turns into a whole number. So this is going to be 1. So I go to 6, I plug in a 1, and we can kind of see what's going on the graph here too. It's approaching those two asymptotes on either side. So this side of the graph is going to sort of look like this. Okay. All right, let's do another one. So in this one, it looks like we have a linear over linear. Okay, so first thing let's do is find the vertical asymptotes. At the bottom equals 0, x plus 2 equals 0, gives you x equals negative 2. Okay, so negative 2 will be our vertical asymptote. So I go to negative 2 on the x-axis and make a vertical line there. Okay, horizontal asymptotes, since the exponents are the same, we have a 2x to the 1 power and an x to the 1 power, so the highest power of x are the same, then we'll divide these coefficients. 2 divided by the number front down here is a 1, so 2 divided by 1 is 2. So we get y is equal to 2 is our horizontal asymptote, so that'll be right here. Okay. And now for the x-intercepts, remember what I said earlier, you only need to set the denominator equal to 0. So 2x plus 5 equals 0. 2x equals negative 5, and x is equal to negative 5 halves. That's negative 2.5. Okay, so on the x-intercept, negative 2.5 is right here. Okay, y-intercept, we do f of 0 to find the y-intercept. Okay, so that'll be 2 times 0 plus 5, and then 0 plus 2, and that's going to equal to 5 halves. Okay, so our y-intercept is y equals 5 halves, okay, which is 2.5 positive, so that's going to be right here. Okay, so we got a couple intercepts there. And now we can do some other points. Okay, so let's make our little t-chart here, x and y. Okay, so some other points, and we want to choose a few that's left of the vertical asymptote and a few that's right of the vertical asymptote. Okay, so let's do right first this time. So let's plug in an x equals negative 1. Doesn't look like we have a point there. So x equals negative 1. That will give us, let's see, 2 times negative 1 plus 5 over negative 1 plus 2. Okay, so that's negative 2. That'll be a 3 on top and a 1 on bottom, so we get 3. Okay, so negative 1 gives us 3 right here. Okay, it looks like we're going up here. Okay, so as we approach this asymptote, it appears we're going up. So if I plug in something like right in between here, I'll probably get an answer or a point somewhere up here. So let's plug in one more of those. Let's plug in negative 1.5. Okay, so that would be 3 halves. Okay, so I'll plug in 3 halves, and it's negative 3 halves. So negative 3 halves would be 2 times negative 3 halves plus 5 divided by negative 3 halves plus 2. Okay, so let's see, the 2's cancel there, and we get negative 3 plus 5, which is a 2 on top. And then on bottom, negative 3 halves plus 2 is 1 half. Okay, and if you flip and multiply that, flip it up, you'll get a 4. So negative 3 halves, which is here, gets us a 4. So you can kind of see what's going on here. We're going to approach both of these lines here. And it's possible that it could go under. I don't think it's going to, but it will be guided by this horizontal asymptote. All right, let's try some on the left. So we've got this point already. Okay, so let's plug in we can't plug in a -2 because that's the vertical asymptote. Let's plug in a -3. Okay, so if I plug in a -3, that will give me, let's see, 2 times -3 plus 5 divided by -3 plus 2. Okay, so the top will turn into, let's see, -6, -1. And then the bottom will turn into -1. So you get 1. So plug in a -3, we get a 1. Okay, so that's going to be here. Let's plug in a -4. Plug in a -4, so you get 2 times -4 plus 5 over -4 plus 2. So let's see, the top turns into -8 plus 5, which is -3. Bottom turns into -2. So that's going to be 3 halves. So plug in a -4, we get 3 halves. Okay, so that's going to be right here. Okay, and we should be able to pretty much see what's going on again in this function. Okay, and there is the graph.